we have to tell whether it's like nucleophilic one or the electrophilic one.
Exactly. Which one is this? From either of your choices, it can be only one. It can't be nucleophilic and electrophilic at the same time. So which one would you choose?
So electrophilic because the double bond will be broken.
Exactly. Okay. Now, this should give you an idea about the reactants. This is the reactants, though this is very confusing. When this question came out and confused a lot of students, I'll come to that a little later, but let's talk about this one. CH2 is ethene. We can use I2 as per the written question statement, and we can have the CH2 and the double bond would be broken into single bonds, and then we can have one I over attached over here, one I attached over here. If you take two atoms and you put them equally upon both the doubly bonded carbon atoms by converting double bond into a single bond, that is electrophilic substitution, actually electrophilic addition. So this reaction is based upon electrophilic mechanism, and it's addition because we get a single product. All right. Now, the part where I
All right.
was discussing this question created a big confusion, and that confusion is this this part. Now, your IGCSE book clearly says that iodine can exist in solid form. It only sublimes and converts directly into gaseous form, which means it bypasses the liquid state. Now, this usually gives students the idea that you cannot convert iodine into liquid form. So we can't say that's impossible, but usually when you try to simply heat it, you can actually convert iodine from solid to gaseous and gaseous to solid form. We actually need a little bit other kind of conditions to convert iodine into a liquid form, right? This word liquid, since it only sublimes, was a big confusion for students, but later on cleared out. So moving on to part C. Now, my point being, the point I was trying to make, I'll just go back a little. The point I'm trying to make is that if something comes out of the ordinary and it's clashing with some of your prerequisite concepts, let's say a concept back from IGCSE or a concept that you studied back in the previous chapters of AS, and it gives you a contradiction, an open contradiction, don't think about the contradiction sitting in the exams. If examiners tell you something, just go according to it. You can pretend or you can suppose it as an assumption based question. So you can go with any kind of assumption that's totally all right in a paper. Just go according to it and don't work your brain out and don't exert your mental capacity at that time sitting in exams. How would it be liquid? We only studied it to be solid and converted and directly into gas, bypassing the liquid state. How is that possible? Don't waste your time on that. Even if something else comes as a part of your paper, don't think about that. Just continue with your questions. Just continue whatever you're given with and whatever you're asked about, not by the other things in the paper. I hope you get the point. Okay, let's come to part C. Actually, this is too much organic. Should we skip it for now?
Yeah, for now I think we should.
We'll do organic with organic. Let's stick with what we have at hand. Okay, again, organic. Let's not go with this. Organic product, organic. Yeah, let's start with 5A1. Not exactly the chapter we are doing, but it will actually lead to, in the next questions, what we are supposed to do related to chapter 17.
Because it has oxidized chlorine from the oxidation state of -1 in HCl to an oxidation state of 0 in chlorine gas.
Good, very good. Number 2. Now the visual observations.
The solid disappears.
Right, good. Remember, we have studied MnO2 as a black solid back in IGCSE when we were experimenting it as a catalyst for H2O2 decomposition. So yeah, the black solid disappears. That is one of the many observations. Since it's producing gas, so you can go with fizzing, effervescence, the color of the gas. There are many things that you can answer in this question. The solid disappears is one of them. All right. Volatility trend, part B.
Volatility decreases because the intermolecular forces between the molecules are getting stronger due to the increasing number of electrons.
Perfect answer. Okay, let's see what do we have over here. Yeah, we are done it with like 2 to 3 times. So let's not go with the
Yeah.
disproportionation equation of NaOH and chlorine. No, neither D. Mhm. Again, the trend of volatility. B1. Although it's too easy, but sometimes it tries to confuse a few students.
Sunlight.
Right, light. Light, sunlight, UV light, whatever you answer. In this case, it would be correct. Okay, 2 is too easy. Let's skip it. We're done with this. Let's go with this one. 1 is easy, but yeah, let's start with C1 since this is a progressive question.
With C1 or C2?
C1,
Proton donor.
good. 2,
HCl would be the acid, and the conjugated base would be the chloride, Cl minus.
good. 3,
Coordinate bond.
coordinate covalent or dative bond, right? And finally, 4,
The shape would be trigonal bipyramidal, and the bond angle would be 107.
Can you repeat the shape?
Trigonal bipyramidal. Bipyramidal.
No, that's not right. Okay, do understand the point that if it has three corners, we call it trigonal. And if it
Planar.
shows a pyramidal structure up top and a pyramidal structure at bottom, which probably means there are two atoms over here, two maybe group of atoms or atoms, then it's bipyramidal. But if we talk about the specific structure, oxygen is in the center. There are two hydrogen atoms that were previously attached with water. Then there was one lone pair which was given to an hydrogen ion, the third bond, and finally we have one lone pair. So we can't calculate this lone pair. There are three bonds and one lone pair. It can't give you a bipyramidal. So
Bipyramidal is for 120 and 91.
Which one?
The bond angle in which it is 120 and 90.
The one
What's
up
the
top,
shape name?
bipyramidal, yes, 120 and 90.
Okay.
But this one is not, since this one is not bipyramidal, this one is just trigonal pyramidal. Why? Because these 3 points, this one, this one, this one, acts as a trigonal base, like this. And this lone pair actually exists as a pyramid up top. So it's trigonal pyramidal, not bipyramidal.
All right, got it.
There will be only one pyramid, which is the lone pair. Of course, it needs more space.
Yeah,
Since it has more repulsion forces. All right. So what about the bond angle?
All right. 107. So like 3 bond pairs and 1 lone pair.
Right. 3 bond pairs, 1 lone pairs. It is almost equal to what ammonia has. I mean, since ammonia is around 107.
Yeah, ammonia.
So we will also consider it as 107. Good. Okay. Moving on. 7A1. Let's start with this. It is a logical question and a progressive one at that.
They have a regular arrangement.
You said regular arrangement, right?
Yeah.
Good, good. That's fine. Any words to this understanding? Regular, fixed, definite, uniform, are all correct. Okay, moving on. Part 2.
All right.
One by one. First of all, forces of attraction present.
So the force of attraction present would be covalent bonding and the ID forces.
All right. And forces of attraction overcome.
Only the ID forces? Because won't there be still covalent bonding in the iodine vapor? Like iodine molecules
Exactly,
in the gaseous form?
exactly. In case of simple molecular structures or based upon covalent bonding, what happens is that whenever we heat them to change their state, whether it's melting or it's boiling, what happens is that the forces of attraction, such as intermolecular forces, are overcome. We do not break the covalent bonding of the structure. So, yes,
Right.
ID forces. Moving on. Continuing with the question, would you be able to do this? This is a little bit of
Yeah.
a different question. Wait, what?
I think it's Al2Cl6, but they use iodine instead of chlorine.
Yeah, that I understand, but what are they asking? Iodine reacts. Diagram shows the outer ones. Oh, okay, that's the question. I thought, where is the question? So, yeah, number one.
Two coordinate bonds.
Okay, and number two.
The iodine molecule donates a lone pair of electrons to aluminum. To
Right,
yeah,
that is
two
correct.
two of the iodine molecules donate two lone pairs to the
Iodine
aluminum
atoms.
atoms.
Yeah,
Yeah.
everything else is fine. Iodine atoms. Okay, go with C1 so that you can actually answer C2 for me. I'm not
Right.
specifically
Just a
interested
minute.
in C1, but if you don't do C1, you won't be able to answer C2 for me. C2 is the one that I'm interested in. Go ahead, take your time. I suppose this equation is not going to be easy for you. I mean, it would be time taking. It's not going to be difficult either, but it would be a little bit time taking. Take your time. The recording. What if I tell you your answer is correct, but the point quoted over here also confirms your answer? Will you be able to come up with a reasoning for it?
I mean, for the other reagent, I think the sulfuric acid one,
No.
there's
What
no
I'm trying to
precipitate
say
in it, right?
is that you are correct with silver nitrate. You are correct with the
Yeah.
color of precipitate.
Yeah.
I'm also correct by saying that sometimes we do use nitric acid. We acidify the solution or the system before we can
Mm-hmm.
use silver nitrate. But here, we won't do that. And here, without acidifying it previously, the silver nitrate does give you the yellow colored precipitate. Now, do you know the reasoning behind it?
The reasoning behind?
This, why in most of the cases we need to acidify it, but in this case we do not need to acidify it first. We can use a single reagent, yet it would
Is
give you
it
the
got
colored
something to do with
precipitate we want.
solubility?
No?
No. Mm. Acidic nitric acid.
Okay, for a little bit of good advice, which actually goes with some older papers, uh, we actually need to acidify it for some more reactive halogens. This step of the process that we acidify it is more useful for chloride ions or for the detection of bromide ions, chlorine and bromine being more reactive than iodine. But even if you do not acidify it with iodide ions, you can yet actually detect them with their pale yellow or yellow precipitate. So for a single reagent, if the case is iodide, yes, you can use silver
Mm-hmm.
nitrate, and yes, you won't have a problem getting precipitate.
All right.
But it might be problematic in case of chloride or bromide. So the standard practice is actually to acidify it for all halogens, actually, all halides. So even if you go with the standard practice, that's good. But if your question is about iodide ions and you go a little astray from the standard practice, that's fine. You'll yet get your color of precipitate. This might not be correct for bromide or chloride ion.
Okay.
So number 4.
Concentrated ammonia.
Concentrated ammonia. But I would always suggest using the word aqueous or solution. Or ammonium hydroxide means you tell the examiner that you're not talking about gas, you're talking about its solution. Yes, concentrated ammonia solution. So let's discuss
All right.
how would that
Yeah.
actually bifurcate both things. For example,
For
you use
concentrated
concentrated
ammonia,
ammonia solution, what would happen after it?
the bromide ions, whatever the silver bromide, it will dissolve in it, whereas silver iodide, it's insoluble in concentrated and dilute. But for silver bromide, it's only soluble in concentrated ammonia.
Okay, good. Well done. Okay, moving on. See what we have next. Too many were tilde question. Let's skip it. Too easy. Yeah, let's go with this one. C1.
Okay, so for the first column, there would be a yellow precipitate. Yellow precipitate for the color. The name would be silver iodide, and adding excess, it would be insoluble for the first column. And for the second one, the color would be white precipitate. The name would be silver chloride, and it would dissolve.
Sorry, I was talking with mute on. Yeah, everything's correct except it would be not be silver bromide in the second column. It's silver chloride.
Oh yeah, silver chloride.
Yeah.
I think I said
So
chloride. Yeah.
you might be thinking about chloride, but you said bromide. All right.
Oh, my
So
bad.
this one's easy, too easy. Not go with this. This one's good. Let's go with D. We have done it a couple of times, but let's practice it again. It's an important question from this part.
Okay, so sulfuric acid is acting as an oxidizing agent in both of the reactions. And in the case of sodium iodide, the iodide are stronger reducing agents, so they would reduce the sulfuric acid to hydrogen sulfide, whereas the chloride ions are weaker reducing agents, so they cannot reduce the sulfuric acid.
Good. There are 3 marks, so 1, 2, 3. Yeah, a perfect answer. All right, let's move on. Easy, too easy. Yeah, let's go with this one. This is a good question.
Ionic bonds.
Correct.
And the white precipitate, magnesium chloride, and adding sodium hydroxide. Okay. White precipitate. Oh, sorry, just a minute. There's someone at the door.
Sure, take your time. Yeah, you were saying?
I said I'll give the explanation and observations for M.
Yeah, go ahead.
Yeah, so it has a first of all, it's silicon chloride. It has a low melting point because it's a simple molecular structure, and
Right.
silicon chloride upon addition of water forms SiO2, which is the white solid, and strong acidic solution is HCl, and the white
Right.
fumes are due to HCl as well.
Good. And the
And then we
white
can write the
precipitate,
equation for the
the white precipitate we were talking about previously was magnesium hydroxide in the previous one. All right. So yeah,
Oh, okay. All right.
everything here is correct. Okay, moving on. Too easy. We've done volatility a lot of times. Yeah, 13A.
The thermal stability is decrease as we go down the group because the bond length is increasing, and greater the bond length is, the less energy is required to break the bond.
Perfect answer. Moving on. Easy, you have done it before. Too easy. Yeah, let's start with this one. A1.
The boiling points are increasing because the IDID forces are increasing due to the increasing number of electrons.
Great. And what about 2?
Because hydrogen halide, hydrogen chloride has hydrogen bonding, which requires greater energy to break the hydrogen bonds than it does to overcome the weak intermolecular forces in the rest of the hydrogen halide.
Right. Okay, let's see. Yeah, this is a good one. Go for it. Now, there are pretty open hints in there to identify
Yeah, most
P2 or Q2. Yeah, take your time. That's fine.
iodine is P2, and Q2 is chlorine.
Good. Let's talk about 2. Oh, that's easy. 2 is easy. 3 is also easy. So is 4. Okay, let's try this one.
No.
15. First one. Second one is easy. We'll simply skip it. Let's just go for the first one.
So W is NaClO.
Mm-hmm.
And X is NaClO3.
Right.
And Y is HCl.
Right.
And Z would be silver chloride, AgC.
Good. Forget 3 as well as 4. Too easy. Yeah, B1.
No.
I'm actually asking B1 for the sake of B2. It's not that I'm interested in B1, but it's actually a prerequisite towards B2. And that's the last question for the day. Can you hear me?
Yeah.
So yes, about the answer.
Calcium chloride and sulfuric acid would give CaHSO4, or one would be HCl, one of the product, and
Yeah,
the other one.
CaHSO4 twice. HSO4 has a negative charge, calcium is +2, so it must be twice.
Oh,
And yes, you're
okay.
right.
HSO4 is also a complex sign. All right.
So what
So
about B2?
because the hydrogen iodide, the iodines are stronger reducing agents. Actually, okay, oxidizing agents. Because the hydrogen iodines will get oxidized, and hydrogen iodide form would not be pure.
Yeah, but it would get oxidized by H2SO4,
By
or
the H2SO4, yes.
it would produce iodine instead.
Yes.
Because the reaction does not simply stop at hydrogen iodide. Further oxidized, then there you go, it is converted into iodine. So that's about it. Let's start from the next one on the next sitting.